channel, and in this video we are going to learn about CPU scheduling in operating systems. So let's see what is CPU scheduling. It is basically a process used by the operating system to decide which task or process gets to use the CPU at the particular time. So operating system, the term is nothing but it acts as an interface between the hardware and the user. So now CPU scheduling, it is nothing but at what time what process gets executed. So in a system, the CPU, it cannot be idle. Okay, so CPU has to run because there are many processes that have to be completed. So that's the reason CPU is continuously running in a system. So the purpose of CPU scheduling is, the first one is maximizing the CPU utilization, and the second one says to minimize the response and waiting time of the process. Okay, waiting time and response time. These two terms might be a little confusing right now, but you'll understand it later when I'll explain it to you. Okay, first let's see the terminologies. That is arrival time. Arrival time is nothing but the time at which the process arrives in the ready queue. That means when your process, suppose you are having some processes like P1, P2 and so on, and this is the Gantt chart we use. So at the time when P1 comes into consideration into CPU scheduling, this is called as the arrival time. So P1 has arrived at 0 time. Okay, so that is arrival time. Completion time is nothing but the time at which the process completely executes. Like suppose P1 has to execute from 0 to 5 units. Suppose here it has been completed. So this would be the completion time of P1. Next comes the burst time. It is nothing but the time required by process for CPU execution. Like those will also be given in an example actually. You'll later understand it when I give you a problem. So 5 to 5. Suppose this is the arrival time and this is the burst time. So it says that some process P1, it has arrived at 1 unit time, and then how much time it has taken for execution, it says that burst time. So P1 took 5 units of time. It's not seconds, it's not hours, it is called as 5 units. Next is turnaround time. It is nothing but the difference between the completion time and arrival time. Next comes waiting time, time difference between turnaround and burst time. Okay, so there are two different types of scheduling methods. The first one is preemptive scheduling and the second one is non-preemptive scheduling. In preemptive scheduling, it says that uh, suppose you are having a Gantt chart and here you are having a ready chart. Okay, so it says that a process switches from running to ready state or from waiting to ready state. That means suppose you are running a process P1 from 0 to 2 units, and at 2 units some other time at some other process has arrived in the CPU scheduling, that is P2. So now P2 would come here and P1 would go and store at this ready state. Okay, so this storing process is called as preemptive, and at the end when everything finishes it would again come and join the Gantt chart. So that's preemptive scheduling. So you can switch the process in it without completion of the first process. Okay, so now let's talk about non-preemptive. Non-preemptive is nothing but if this is the Gantt chart and if you have started with a process P1, until and unless you don't finish the P1, the CPU will never give the place to the next process. Okay, so let's see the different types of scheduling algorithms. The first one is FCFS, that is first come first serve. Second is SJF, shortest job first. Next is SRTF. Next is round robin priority scheduling. HRRN, that is highest response ratio next. And next is multiple queue scheduling, multi-level feedback queue scheduling. So these are all the different types of scheduling algorithms. So now let's see FCFS in today's class, that is first come first serve. The name itself tells us that whichever process arrives first, it gets chance for the execution. Okay, and in FCFS it is only having non-preemptive scheduling. Okay, so let's understand this by a question. Here he has given us some processes. There are 4 processes P1, P2, P3 and P4, and the arrival time is 0, 1, 2, 3, and the burst time is 5, 3, 8 and 6 for the respective processes. Now we need to find the average waiting time and turnaround time. So to find the following things, we need to first create a Gantt chart. Okay, so Gantt chart is nothing but this. This shows us which process gets executed for how much time and which process is executed at a particular time. So at Z it starts from 0 always. At 0 which process has arrived? P1 process has arrived. So that's why you will take P1. Since this is an FCFS scheduling, you'll you'll have to follow non-preemptive. That means once a process gets a chance, until and unless it finishes its turn, it will never give its place to the other one. So even if you move up to 1, like up to 1 unit you have moved and the next process has arrived, but you will not give the place to this. So here in this state, a ready queue would be waiting. Okay, so here you will be storing process P2. Okay, and next after 1 unit, so since you will not give it, so how much time you will run it? 5 units. So that's the reason up to 5 units. So P1 would run up to 5 units. Now but to understand this clearly, now if I go the next unit, at 2 unit time which process has arrived? Process 3. So now we can't start the process P3 because P1 is already running. So now we'll store it in the ready queue state. Okay. So now again this P1 would move one more unit, 3 units. Now what process has arrived? Process P4. So but P4 cannot run in this because it is FCFS. Until and unless P1 don't complete its execution, the next process will never get a chance. So that's the reason P4. Okay. So now P1 will move another unit, that is 4. There is no process arriving. Now next it would complete its execution. So at 5 units P1 has completed its execution. So the next process which is in the ready queue is process P2. Now the process P2 has arrived. So now P2 will move how many units? It will move from 5 to 3 units, that is 5 plus 3, that is 8. Then P2 is completed. The next process that would come is P3. It would move how many units? 8 units. So it is nothing but 8 plus 8, 16. Next process is P4 and it would move 6 units. So it is 16 to 6. Okay, that is 22. Okay, so now we need to write completion time. Okay, completion time is nothing but when the process gets completed. You should always for writing completion time, you should always move from right to left. So the first process is P4. At what time it has got completed? At 22. So that is its completion time. Process P4. I'm sorry. Process P4. It is 22. Process P3 has completed at what time? At 16. Process P2 has completed at 8. And process P1 has completed at 5. So this is completion time. Now what can we find? We are having completion time and arrival time. So we can find turnaround time. Okay, that is nothing but completion minus arrival time. What it is? Completion is 5 minus 0. 5 minus 0, that is equal to 5. The next one is 8 minus 1, that is 7. Next 16 minus 2, that is 14. Next one is 22 minus 3, that is nothing but 19. Now we have found turnaround time and burst time. What we can find now? We can find the waiting time, that is turnaround time minus burst time. So this would come out to be 5 minus 5, that is equal to 0. And for process P2, turnaround time is 7, burst time is 3, so it is 7 minus 3, that is 4. And for process P3, turnaround time is 14 and burst time is 8, so it comes out to be 6. For process P4, turnaround time is 19 and the burst time is 6. So it is 13. So we have found the turnaround time and waiting time. So what is our question? It is to find the average. Average is nothing but adding all of the following and dividing it by the number of processes it is having. Okay, so let's find. For average waiting time, we simply add all the waiting times, that is 0 plus 4 plus 6 plus 13 divided by 4. This comes out to be 6 plus 4, 10. 10 plus 13 is 23 divided by 4. It is nothing but 5.75. Now average turnaround time. You need to simply add all the turnaround times, that is 5 plus 7 plus 14 plus 19 divided by 4. So this is 21. 21 plus 5 is 26. 26 plus 19 is nothing but 45. So it is 45 by 4. And this comes out to be 11.25. Okay. So this is the average turnaround time. So hope this concept is clear. And here is a small homework problem for you. The same 4 processes have been given. You need to find average waiting time and turnaround time, and that would come out to be 7.25. The average waiting time and turnaround time would come as 12.25. If you have got this answers correct, then do comment your answers below in the comment section. If this video was helpful, then don't forget to like, share it with your friends, and if you are new to my channel, then don't forget to subscribe to my channel, and see you in the next video. Until then, bye bye.